Hello, everyone. Welcome to session TUT 1014. Today, we're going to be discussing the pod security policies, PSPs, and pod security admission, PSAs, with Kubewarden. Today, your presenters are going to be myself, Mike Roberts, and Martin Weiss. We both work in the consulting team. I'm relatively new. Martin has been a consultant for a very long time. We are both technology consultants. As I say, we work in the consulting team. So today we're going to go through the agenda first of all. Why are we making these changes? Our motivation, and also detail on the requirements. We've got the PSP or pod security policies versus pod security admission, the differences between them, what you need to know. Then we're going to discuss Kubewarden, which is an open source product that SUSE has donated to the CNCF. And then we've got the migration from PSP to PSA with Kubewarden. Martin's going to drive the slides there and do the presentation from that on. So as I said, our motivation, why do we need to move away from PSPs? The reason is the CNCF has deprecated the Kubernetes or the PSPs and Kubernetes version 1.25. So any customers that still need container security or CIS profiles or PSPs and network policies are going to have to make the change. The migration is needed to PSAs with the addition, well, if you need to with Kubewarden, when you migrate to Kubernetes 1.25 or afterwards. So next is the requirements. We need an upgrade in security. That's the main reason. So as I said, if we're upgrading your Kubernetes to version 1.25 or any later version, this is going to be needed. We need to keep container security or actually improve container security. We need to force cluster participants to limit not only resources, but also security. So the existing features are do not run as root, do not access local volumes, and do not access host network. The new features that have been added will be the only run images from registry.rancher.com and also only run signed images. This is from a security benefit. Then we're going to go through the design and architecture. We've got the architecture of the PSPs and the PSAs. So many of the PSP objects had different settings, so they were cluster-wide. One default PSP was for the entire cluster. It could have been restricted or not. And there were normally exceptions were done via a service account. Then we've got PSAs. There's just sort of three default PSA rules: privileged, baseline, and restricted. The differences are really is privileged allows for known privilege escalations. Baseline is prevent known privilege escalations, and restricted, following current pod security hardening best practices. The assignment types, we had three, which was enforce, audit, or warn. Difference between them is to enforce was to block entirely. Audit would be audit the violation in a log, but would still allow it. And warn would send a warning, but would still allow it. Now, why is pod security admission not enough? Restrictions are not enough and less flexible. The additional requirements for security and allows signed images, required specific labels on specific objects and specific namespaces. So PSA for minimal security by default. And if additional security engine is required, today we're going to discuss Kubewarden. And if PSA and Kubewarden aren't enough, we do have another product in our stable, which is referred to as New Vector. It's also an open source product, but there's it's designed with security in mind. It's a company that SUSE acquired a while ago and then donated. But today, we're not going to delve very much into new vector. We're just going to have more of a look at Kubewarden. So, what is Kubewarden? Kubewarden is a policy engine, and its adoption as policy as code. So that way it's repeatable and is easy to read and to implement. So as a policy author, Kubewarden doesn't force you to learn a new language, which some of the other competing products do, and you can write them in your favorite language. So I think these days we have to know a lot of products, a lot of languages. Anything that we don't have to learn is a definite advantage. And if you're the operator, it can be distributed using existing container registries. So there's no need to reinvent the wheel, and it's easy to experiment with policies. And then you can integrate them into your CI/CD pipeline, whether it be Fleet, Argo CD. Then, how does Kubewarden work? It provides a set of custom resources. It's to simplify the enforcement process. Policies are implemented as WebAssembly hooks and modules. There's a policy server, a Kubewarden policy server. Everything is contained within there. Sorry, 1 second. Kubewarden policy server is a webhook, and it has each policy is a dedicated endpoint. Policies are isolated from host and from each other, and every single policy is confined inside a dedicated, secure sandbox. So what we've done is put a bit of a diagram here to explain it. So this is where we have our Kubernetes control plane and data plane. We have the policy server, and this will be your CI/CD pipeline. It'll come through your controller, where it will push through to the policy server. If anything's unclear. Now, migrating from PSP to PSA with Kubewarden. I think this is where Martin sticks in. Yes.
Okay, I guess. Yes, thank you very much, Mike, for the explanation. Basically, now I will talk a bit about the migration steps that are required when you're on PSP clusters and you have to move forward to PSAs with or without Kubewarden. Basically, the whole starting point will be on Kubernetes 124. That's the latest version when you have to switch from PSPs to PSAs, because with the upgrade from 124 to 125, the PSPs will automatically be removed, and that brings some security challenges. So if you would upgrade right away without doing anything, you would lose the security protection that you have with PSPs in your cluster today. So the starting point is basically Kubernetes 124. We assume that you have PSPs enabled by using the CIS profile 1.6 in, for example, RKE2. And as a first step, you have to enable PSAs in addition to the already enabled pod security policies in your cluster to make sure that when PSPs get disabled, you still have your security per default in your cluster. Because PSAs are managed in one central default configuration plus on labels on given namespaces, you have to review what's the process in your environment for creating new namespaces. Basically, whenever you have the right to create a namespace and the right to label the namespace, you can override the default security settings that are given by the default settings in the PSAs. And for that reason, everybody who has the right to label a namespace can give himself privileged rights for content of the namespace, which you might not want to have. So first of all, check the namespace creation process and probably ensure that the required labels are preset when namespaces are created, or that people don't have the right to change labels on namespaces to make sure that you still have the security you want to have in your cluster. The next step is, before enabling PSAs, basically when we enable PSAs, we would highly recommend to use restricted per default, which makes your cluster secure per default. But in that case, nothing in your cluster that requires privileged access will work anymore. So to have exceptions to the default, you have to set the expectations, the exceptions via labels on the existing namespaces before you enable restricted pod security admission for your whole cluster. Which means, for example, for kube system namespace or kettle system, if you're having rancher, etc., you have to see where do you need privileged containers. And on all these namespaces, you have to set the labels to override the default and allow permissive access for the pods in these namespaces. So after you have set these labels, the next step is you activate pod security admission in the config YAML if you're having RK2, or check the other Kubernetes distributions how to do that. I'll show in a few minutes in a screenshot how to do that with RK2. And because pod security admission has less flexibility, as Mike explained, when it comes to policy details, you might want to replace these additional functionalities that are in PSPs but are not in PSAs with our policy engine Kubewarden, which means before disabling PSPs, you also have to deploy Kubewarden. And once you have deployed that, you also have to configure the required Kubewarden policies that basically should take over the functionality of PSPs that are not included in PSAs anymore. Or what you also can do is you can even further improve the security by adding more policies on this level. For example, with these policies, you can also control that new namespaces get the correct labels for pod security admission and things like that. So once we have enabled PSAs and Kubewarden on top of the PSP enabled cluster, the next step will be to disable the PSPs. A very important point here is disabling PSPs at this stage does not mean uninstalling or deleting them, because many of them came with Helm chart-based deployments or with operators somewhere. And if you would delete them automatically, the Helm charts would later have a problem when they want to delete them on their own, and you have deleted them beforehand yourself. So this can be a problem, and due to that, we disable them, which means we assign new role bindings where we basically give every service account in the cluster the right to use the permissive pod security policy, but we are not deleting any of them. And the next step then is we have to reinstall, or better, Helm upgrade all existing deployments in the cluster that have been configured to install and configure pod security policies. So for example, rancher monitoring or rancher logging. Many of these applications had an option in their Helm values to set PSP enabled, yes or no. And if you had yes in these deployments, the Helm installation automatically created these PSPs, created roles and role bindings for you. And at this stage, before we upgrade to Kubernetes 1.25, we have to do Helm upgrade with modified values where we disable the PSPs that came with the Helm charts. So this will basically delete all the pod security policies that have been delivered with Helm charts. Maybe as part of this, you can also upgrade one or the other thing. For example, you can upgrade rancher monitoring from a previous version to the newer version and change the setting as part of that one. But if you don't change the version, update the application with PSP disabled. So after you have done that, this is the point in time when you can upgrade to Kubernetes 1.25. And as part of this, for example, when you're using RK2, you also have to change the CIS profile from 1.6 to 1.23 in the configuration, because 1.25 only supports CIS profile 1.23. And as part of this, PSAs will automatically configured and network policies will also be enabled. So this is basically the picture how to move from 124 to 125 with the move from PSAs to with the move from PSPs to PSAs and adding Kubewarden. And now I'm going through a few screenshots with the detailed configuration. So this is just an example of the labels where we configured the additional labels on existing namespaces. So in this example, you can see, for example, for cert exporter and Jaeger, we have set the label pod security Kubernetes IO/enforce equals privileged. So with the restricted setting for the whole cluster, we are overriding for these namespaces that within these namespaces you can run privileged pods. Without this label, Jaeger or cert exporter would not even start anymore because they would be blocked by the pod security admission. So this is basically the point where we are adding the labels before we enable PSAs. And for future deployments, you also might have to add these labels to new namespaces when you're deploying applications there that need privileged containers. The next thing I'm showing here is the configuration of RK2. So when you want to do pod security admission on RK2 124, you have to do two things. You have to create that rk2-pss.yaml file. This is basically the place where you do the default configuration for your pod security admission. So in this example, basically you can see that we are setting enforce to restricted, which basically makes the cluster secure per default. I could even change this here to enforce privileged, which would basically disable the pod security in the cluster. But as we want to have security per default, we always set enforce restricted in environments where we want to have security. After you have created this default configuration file, you have to enable it as well in the config YAML with this admission control config file parameter, and then restart the RK2 server process to make sure it's also used. And then you have the PSA enabled for your cluster. One word about the exemptions here. At the lowest line here, you can see that there are a few namespaces listed as exemptions, which means in these namespaces, for these namespaces, you don't have to set the label permissive. These exemptions just make sure that if this namespace exists, anything can run in this namespace. Please be careful with the namespaces listed here, because if you list a namespace that does not exist in reality, and somebody later creates that namespace, he can do whatever he wants in that namespace. So these exemptions basically are some sort of a backdoor from a security point of view, and they should be as less as possible. All right, the next thing is deployment of Kubewarden. So Kubewarden you can deploy in multiple ways. They are part of the Rancher app store. So within Rancher you can install Kubewarden with the UI. You can install Kubewarden via Fleet or any other CI/CD pipeline or CI/CD system that you have. And when you're deploying it, basically there are a few Helm charts for different components. So we have the Kubewarden controller Helm chart, we have a CRD Helm chart, we have Kubewarden defaults Helm chart, which basically configures a set of default policies for you. But you can add your own policies, as many as you want. In this example, I'm just using Fleet, but there are multiple different ways. And what you also have to keep in mind is for Rancher, we have a Rancher extension. So you get a wonderful UI in Rancher to manage Kubewarden. And the policy server on the policies, we have an integration into Prometheus metrics and have a Grafana dashboard. And we have integration into Jaeger and OpenTelemetry, so you can see exactly what and when happened with the policies, when have they been used, when did they block something, etc. We have a monitoring way, we have a blocking way in the policies. So after you have deployed that, basically there is a huge list of policies that we already developed for you, or the community developed. And there is on Artifact Hub, you can get these policies. Basically, they are just, you handle them like simple container images. You can fetch them from there. You can put them in your own on-premise registry. You can use that air-gapped if you want. Or if you're using the Ranger UI, you can click on Create New Policy, which will automatically give you a list of the available policies in that Artifact Hub. And each of these policies, when you select them, has the pre-developed code for the policy, and it has, depending on the policy, what it should do, several parameters that you can adjust. Policies can be cluster-wide, but policies can also be scoped on different objects, different namespaces. So this is extremely flexible. And you can even develop your own policies, but the challenge with developing your own policies is always the testing and making sure that everything works in every scenario. So that's why we deliver pre-developed and pre-tested ones, where you only have a few parameters that you can adjust. So you don't have the need to write your own code and test your own code with each and every scenario that you can think of. This is a command that I just wanted to share how I create the pod security policy role binding, so that when you want to disable the PSP in your existing cluster with this command, you can basically assign the unrestricted PSP to all the service accounts of a given namespace and disable the restricted PSPs. So, and last but not least, some of the Helm charts we deliver, but also many others have this option of PSP enablement, where I said you have to upgrade or Helm upgrade your application with PSPs enabled set to false. And once you have done that and all your applications that are running in the cluster don't have pod security policies as part of the Helm chart delivery anymore, you can go to Ranger or any other way that you're using to upgrade your Kubernetes cluster and upgrade it, and you're done. And with this, basically, we are done with our session. Thanks a lot for watching. Feel free to reach out to the two of us. So you can reach me with martin.weiss@suse.com, or you can reach out to Mike, mike.roberts@suse.com. We are more than happy to hear about feedback, positive or negative. We also want to learn. And if there are any questions, do not hesitate to send them over, and we're looking forward to help you with this journey, keeping your environment secure. Thank you very much, and have a wonderful SUSECon.
Thank you, everyone. Chat later. Cheers.